Thank you. Can you hear me? Yep. Great, thanks. Not only cars. 2014, May 2012, Google passes Nevada's driverless car test. That was the beginning of the driverless car revolution that we are currently experiencing. And it's war. It's total war between the big car companies, Ford, GM, Mercedes, BMW, and Tesla, and between themselves, and also with Google, Apple, Intel, Uber, etc., the software companies. And why is it war? Why is suddenly everybody interested in being the first or the best in driverless cars? And everybody saw Simon Stewart's presentation. Nobody noticed that what he said was that at most you can be 75% happy. You cannot be 100% happy. You know, anybody remember why? Because 25% of that time, of your time, is spent commuting. And you are angry, just like she is. And it's boring. And the car companies know it, and the software companies know it, and they're trying to solve that problem. If we have driverless cars, it becomes less boring. And we can be 100% happy. And not only is it boring, that's fine, okay, hey. The proletariat can be bored, we don't care, but it's dangerous. People text, people don't notice, and car accidents happen. Driverless cars at least promise us a non-accident-free, an accident-free future. And if we had driverless cars, we can start concentrating on where we want to go, what we want to do when we do there, and just stop thinking about the technique of moving from one place to another. And just like with testing, that's strange. Okay, I'll figure it out. Just like with testing, the same goes for testing. If you think about that, writing tests that test your application is a somewhat boring job. There is the interesting part, which defines what we want to test. There's the interesting part of building infrastructure that allows us to test, but a lot of times all those tests are pretty boring. This is very, very similar to driverless cars. And this is what I want to do. I want to talk about the similarities between driverless cars and automating the automation and making those tests be run by an AI, and seeing what needs to be done and what is being done and what needs to be done to do those things. So, this is me. As you said, as I was said, actually everything is here is already said, so I'll just skip it. Let's talk about autonomous driving. Let's talk about that, and then we'll see the parallels in autonomous testing. So, they're actually here. They really are here. Google has autonomous cars. Tesla has autonomous cars. And they're driving lots and lots of miles. 222 miles in Tesla. And I don't remember the number. In 2017, it was 3 million miles. So who's winning the war? Is it Google or Tesla or somebody else? And theoretically, the answer is obviously Tesla. They're doing a lot more. But that's not that simple, because Google's autonomy is much more advanced than Tesla's or any else. But how do we define what is advanced and what isn't? And the answer is, it was defined by a Society of Autonomous Engineers, the National Highway Traffic Safety Administration. In 2014, I think, they defined 5 levels of autonomous driving. And let's go through each one of the levels and understand what each level means. And we'll try and create parallels in autonomous testing, for autonomous testing. Level 0, it's actually 6 levels. Level 0 is, hey, congratulations, you're the proud owner of a level 0 autonomous cars. Level 0 means no autonomy whatsoever. You're driving, no AI there. Level 1, driving assistance. That is what we have in cruise control systems and autonomous braking. Autonomous braking is where you're driving and you don't notice, but there's a car in front of you that just stopped, so the car is stopping for you. It actually works. I tried it once, and it's amazing. The guy told me, just drive. And I say, but there's a car in front. He said, just drive. And I just drove, and the car stopped, which is frightening in a way. But it works. The question is, how? And the answer is, what happened that we now have this, but we didn't have it before? And the answer, as usual, is technological advances. And there are two technological advances that made this possible. Level 1, driving assistance. The first is it's all about vision. LiDAR is the main technology used here. LiDAR is light detection and ranging, which means you have these pulses of laser light thrown around by the car, seeing what comes back and figuring from that what's going on around you and what exactly is the distance between what's going on around you. It's 3D vision. It's a bit similar to what Face ID is doing, except for cars. Face ID in the Apple iPhone 10. It's not only LiDARs. We have stereoscopic cameras. Tesla doesn't have LiDAR, but they're saying that stereoscopic cameras are enough. Maybe. I don't know. I'm not an expert. And radar. Some cars use real radar to see what's going on around them. That's one technological advance. Seeing, enabling the car to see what's going on inside. The second thing, and I'll just grab my water. The second thing is advanced algorithms. Seeing is nice. Okay, so I know what's going on around me, but I need to understand it. And the algorithms to understand what is being seen were developed these past years. These are not AI algorithms. For level 1, we do not need AI. We do not need machine learning and deep learning. We just need really, really good algorithms to do that. And those algorithms were being done. And we've got level 1. Level 2 is partial automation. This is what you have in Tesla cars. It's the ability to take your hands off the wheel and let the car drive in a very unsafe. You cannot just leave it and go to sleep or leave it and read. You still have to monitor all the time, but you can let the car drive in certain situations. And when the car feels, well, feels is an interesting concept for AI, but when the car feels that it's not possible, it will beep and you get back control of the wheel. So this is partial automation, and this is a real advance because the car is now driving. And what happened? In terms of vision, we're done. LiDAR is the current standard and everybody uses it. But what made this possible, the ability to drive a car itself, is machine learning and deep learning and neural networks. And people call it algorithms, but it's actually not algorithms. And I want to talk a little bit now about what exactly are neural networks, what exactly is machine learning, and what exactly is deep learning. So let's talk about neural network. This is a neural network. The little circles are neurons. They're not real neurons, obviously. We're not taking a brain and connecting it sci-fi-like, horror movie-like to a car, but we're simulating neurons. So how does a neural network work? It's an input-output algorithm. We input numbers. That's the x1, x2, x3, and x4. And it goes through the layers of the neurons. We'll talk in a second about how. And it comes out as numbers. But we treat those numbers not just numbers. We treat them as classification information. And let's talk about an example. There are lots of kinds of neural networks. Let's talk about convolutional. Convolutional neural networks are used to process images, vision. Okay, and that's the most important thing for us. So the numbers that come inside here, the numbers, the x1, x2, x3, are the pixels of the image. Those are the numbers that enter into a convolutional neural network. You know, pixels are just numbers. There's the R, the G, and the B component, each one between 0 and 255. So theoretically, I can take that image, just throw it at a neural network, and out comes what? What are the numbers that are output? That's the classification. And the classification means this is a dog with 94% accuracy. Maybe it's a cat, maybe it's a bird, but it's probably a dog. Or in the case of the second picture, it's probably a cat. That are the classification numbers that come out of a convolutional neural network. But how do neural networks work? Okay, we have this cool picture. Let's zoom in to one of the neurons. This is a neuron, and this is, in a way, how neurons in your brain work. That was the idea. Neural networks were, I think, invented in the 70s, maybe 80s, but there wasn't enough computational power to make them really effective, so they got lost in the shuffle, and we're coming back to them only now when we have the computational power. How does a neuron work? A neuron gets inputs, again, numbers, regular numbers, applies, and sorry for the math, but applies weights to them. So the numbers are multiplied, each number is multiplied by a weight, a corresponding weight, W1, W2, W3, and then we sum it up. We just sum up the sum of the weights multiplied by the input numbers, go through a function, it doesn't really matter, and that's the output. The sum of the numbers multiplied by the sum of the weights multiplied by the numbers. That is all a neuron does. There's no magic beside it. That is everything. And it is the basis, and we'll see how, of the whole thing. And it's amazing that this simple thing makes us, allows us to drive a car. And we'll see, now let's zoom out. Sorry, let's zoom out. And the reason we want to zoom out is we want to figure out how the whole thing works and who decides the weights. The weights are numbers that are static. They are numbers that define the algorithm. Somebody needs to determine the weights. How does that work? And the answer is training. It's called training data. And the idea is this. Let's take the dog-cat example. So we start with random weights. We'll just throw in random weights. Now put in the picture of a dog as input. That's the x's. And notice how the neurons are connected to each other. So the x's go into a neuron, and that output goes into other neurons in the next layer, and the output of those neurons goes as input to the next layer, et cetera, et cetera, et cetera, et cetera. So first of all, we take the picture of a dog. It flows through the neural networks using the weights thing that we discussed, and out comes numbers. Now the algorithm goes, okay, does the number say that it is a dog? If so, perfect. The weights are good, and we give it the next dog, and the next dog, and the next dog. But what happens if the classification that comes out says that it's a cat? Well, we backpropagate and fix the weights. How does this backpropagation work? Difficult, lots of calculus, whatever. It doesn't really matter. It fixes the weights, and the next picture of a dog will probably be better. Now we throw thousands of dogs, picture of dogs and cats at it, fix the weights, fix the weights, fix the weights, until finally the weights make the neural network do what we want, which is differentiate between a cat and a dog. And that is amazing when I think about it. Think of it. The algorithm is basically very simple. And if you ask an AI guy, a machine learning person, okay, but how does this work? How does it know to differentiate between a cat and a dog? And the answer is, I don't know. It just works. And that's amazing, because AI people do not know exactly how neural networks work, but they do know that the whole training and backpropagation just works. And they're thinking that maybe this is the same for how our mind works. Maybe. So the important thing is that we need a lot of data to train the network. And I wanted you to also keep in mind that neural networks are one-trick ponies. And I'll remember that because I'll talk about that at the end. If you want to train it to discover animals, to figure out animals, you have to train it with lots of animals. That same neural network, will it work with people's faces, for example? No. You need another set of training. With buildings, another set. With figuring out how to drive, no, that's another set. So each neural network is a one-trick pony. And remember that because it's important for your jobs. We'll find it out. And this is why mileage numbers, everybody's talking about how many miles. Google is 3 million, Tesla is 22 million. Why is that important? Because mileage, the data that is working, is going back to train the neural networks that drive the driverless cars. The more data we have, the better and more efficient the neural networks are. What's the difference between machine and deep learning? I've talked to a lot of AI people, and it's basically the amount of neurons. That's about it. Deep learning means lots and lots of neurons. Machine learning, we can get by with few neurons, less computational power is needed, and we have a few tricks to make it work, even if I don't have a lot of neurons. But in the essence, machine and deep learning are ways to use neural networks to classify things. And remember, we need lots of inputs and tons of neurons and layers. But what has this got to do with driverless cars? I mean, birds, cats, fine, but driverless cars. And the answer is, there's not one way deep learning and neural networks are used in driverless cars. There are lots of ways. One way is figuring out the traffic signs. So we've got a neural network that gets the image, the current image that is and figures out that there's a traffic sign that says, don't pass 50 miles or kilometers based on whether you're here or elsewhere in the world. That's one neural network. There's another that figures out the angle. In comes the road, the image of the road, and the LiDAR information, and out comes the angle of the steering wheel. Believe it or not, that is it. There's the neurons inside, the image goes in, out comes the angle. It is that simple. But we need, remember, lots and lots of data to train that. So level 3, well, we talked about level 2. Level 3 is conditional automation. Much more autonomy. Humans need not monitor. Tesla isn't there yet. Humans need to monitor. The idea is hands off the wheel. You can not even look at what's going on. If there is a problem, the AI will tell you about it. And the difference between level 2 and level 3, better algorithms, more training data, much more sophisticated neural networks. Level 4, high automation. This is where Google is at. It's actually not Google, it's Waymo. They split the company, and Waymo is the driverless car part of Google. You don't need a steering wheel, because level 4 means all good. You don't need to monitor. The car will never tell you to go back to the wheel because it can't handle anything. It will work under certain conditions. Google is at level 4 and not at level 5 because snow, fog, hard rain, it can't handle that. But in regular driving conditions, it will handle without a steering wheel, without human intervention. I believe Google is the only one in level 4. Level 5 is full automation. That's the holy grail. Nobody's there yet. Just works everywhere. Snow, hard rain, sleet, fog, whatever. It works. Those are the 5 levels of car automation. How does this work in autonomous testing? Let's try and figure out what those levels are in autonomous testing. And how did this talk even start? Well, I'm not an AI guy. I hope you noticed that. But I do sit next to the AI people. Our AI team and I sit next to them, and we started talking. And they taught me all about machine learning and deep learning and neural networks and sent me information, et cetera, et cetera. And I talked to them about the 5 levels of car driving. And we said, hey, why don't we define 5 levels of autonomous testing? And we brainstormed a lot for a couple of days, trying to figure out what are those levels of autonomous testing. And I hope that the answer will satisfy you. I think it's a good answer. First of all, level 0, just like in cars, no autonomy. Congratulations. Assuming you're writing test code, then you're doing autonomous testing. Notice that no autonomy does not mean manual testing. Okay? In my book, level 0, no autonomy means you are writing the test code and you are writing the checks for the test code. You're writing the whole thing. No AI is helping you. That's level 0. Level 1 is drive assistance, if you remember from cars. And what was the differentiator for level 1 driving? There were 2 differentiators. The first one and the important one, the vision. It's all about vision. Level 1 is all about vision and understanding whatever you can see. If we can look at the app, then we can understand it better. We can take that input and drive it to the AI and make it understand things. How can visuals help? And the answer is, if you look at any test that you have and you know, make it as abstract as possible, it works like this. You do an action, click, another action, action, and then you validate that what you're seeing is correct. The fields are okay, the DOM elements are correct, et cetera, et cetera. Then you do more action, more validation, more action, more validation. That is how all tests work in some sort of another. Level 1 talks about validation, and we'll see that also level 2 and I think 3. Level 1 is all about validation. If the AI can see the page, can it help? And the answer is yeah. Instead of writing, if you think about it in your validation, you're testing whether this field has this value, that field has this value, et cetera, et cetera, et cetera. If the AI can see that page and figure out the differences from a baseline, and do it as a human would, not by pixel comparison, obviously. That's not AI. That's just a bad algorithm. If it can do it as a human would, then it would help. It would show us the difference between what is expected and what is actually there. And that is level 1, trying to figure out the difference between expected, as we call it the baseline, and the actual. And in a way, you think, okay, I do pixel comparison, that's easy. But it's not. We need really, really complex algorithms to look at the page and understand the differences as a human would. If all the pixels move one pixel to the right, a human wouldn't see it and wouldn't care. It's okay. If the anti-aliasing is a bit different, it's okay for humans. A pixel-by-pixel comparison won't work. We need complex algorithms that look at the page and understand it as an AI would. As I said, it's not just pixels. It is complex algorithms. And level 1 is the ability to see the page and understand it in a complex way. Level 2, call it partial automation. What's the differentiator in level 2? It was all about machine learning. All about machine learning and neural networks. And how would this work? And the answer is, just like in partial automation, we get better. We get better at understanding the pages. We start to understand the semantics of the pages. We start to understand the layout of the page and not just pixel by pixel comparison. Think of 2 pages which are exactly the same. Think of a product page at Amazon. Millions of product pages, but we can't check all of them. unless we understand semantically the layout of the page. If we understand the semantics of the layout, and using machine learning and deep learning and neural networks, then we can figure out whether that page is the same as another page, even if the content of the page is different. That's starting to understand the semantics of the page. We're still driving the tests. Action, action, validation, action, action, validation. We're writing the test. We're still writing the test. We're still figuring out the logic. But the AI is helping us in the validation phase. Instead of writing complex validation code, we just throw it at the AI, just go check. And that is partial automation level 2. Level 3 for me starts becoming really interesting. Level 1 and level 2, in the end, the actual and the expected, we need the expected. We need, this is what is expected of the page. We're still giving it the expected, and when the actual and the expected change, we need to tell the AI, this is a bug, or this is a real change, you have a new baseline, a new expected. Level 3, the AI is starting to look at the page, and this is where training works. Level 3 is the AI starting to look at the page without a baseline and figuring out, this layout isn't right. The fields aren't aligned correctly. Or in this case, this is obviously wrong. I don't need a baseline to figure that out. And we need, but it's not that easy because an AI, as you saw, can't really figure out things. It doesn't really understand. The only thing we have currently to make it understand things are machine learning and deep learning. We need training data. We need hundreds and thousands, and I wouldn't say hundreds of thousands, but definitely in the tens of thousands of data where we tell it, this is a good page, this is a bad page, and it will help it classify, train the AI to recognize what are, in terms of design, good pages and bad pages. So that is level 3. Level 3 is where we're throwing the baselines away. The AI will figure it out. But it's not total automation, because when it figures out that there is something wrong with the page, we still need a human. We still need a human to say, yep, you're right, that's bad, or yeah, that's actually good, because AIs can't yet be that good, as good as humans. Level 4 is partial automation. This is where the AI is starting to write the tests themselves. And I was starting to wonder, okay, that makes sense. The human is handoff. And we're not there yet. We're definitely not there yet. We're level 2, progressing towards level 3. But we're definitely not in terms of, and I was brainstorming with my AI people, with the AI team, how do we do that? And they talked about reinforcement learning. Reinforcement learning is sending it, seeing how people react on the app in production, learning from that, and using reinforcement learning techniques to simulate them, to do whatever they do. So if we got the information from the people that work in production, we can simulate that in the tests themselves. Level 4 is where it gets a bit hazy, so I will continue with level 5. Level 5 is pure sci-fi, I'm sorry. Level 5 is where the AI goes and sits in a coffee shop with a product manager and interviews the product manager and tell me about the product. Oh, those are the requirements. Oh, those are the screenshots and everything, and figures out how to write the tests. I had to put it in because I have no idea. You know, I'm Jewish, I'm from Israel, and we have a saying, since the Second Temple, the destruction of the Second Temple, that's AD 770, a prophecy has been given to fools. So I'm not trying to prophesy here. Level 5 is real prophesying. Level 6 is Skynet. We don't need to train anymore because we're not there anymore. And you cannot have an AI talk without a Terminator picture. So here it is. Please tweet, and let's continue. So are we there yet? Are we at level 5, level 4? Should we be looking for another job? Should testers be looking for another job because AI will take control? And the answer is no. And we saw that. AIs don't really understand. They don't. They're idiot savants. They know one thing well. They are a one-trick pony. And as an example, the top picture is the AI understood that it's a banana. And then these Google, they added a sticker next to the banana, and now it thinks that it's a toaster. Okay? And really, no. I mean, it's obviously a banana. But AI is at that level currently. It's a one-trick pony. You can train it for one thing, and it will do it well. You can trick it, obviously, but it will do it well. But it is a one-trick pony. It still cannot do what we humans are really good at, which is think. So, does your job require thinking? Or is it rote and repetitive? If it's thinking, you're good. Don't worry. AIs won't replace you. Otherwise, if a tool took away the repetitive parts, would you be starting to think? And if you are, you're good. AI will be that tool. Otherwise, can you start thinking? If you can, you're good. AI will not replace you. Otherwise, I'm sorry. AI will be replacing you. So start thinking, people. AI is a tool. It's like a tractor for a farmer. Use it when it comes. Use tools that have AI. Use them, and don't panic, because they will not be taking your jobs away. Thank you very much.
You want to take a couple questions?
Yep. We have 3 minutes, and I will be at the Applitools booth if anybody wants to talk to me about more stuff later.
Can you please repeat what AI means, the abbreviation?
Oh, sorry, artificial intelligence. I think it should be AS, artificial stupidity. Really good at one thing, but that's it.
In terms of the levels, what are the best companies leveled at? Like, are you seeing level 1s, level 2s? Like, how are the best companies?
Did my CEO plant that question? Well, I know of several companies. Mabel is one. AppDiff is another. And obviously Applitools. I believe we're at level 2, progressing towards level 3. There aren't a lot of AI companies, and each is seeing the big elephant, you know, in a different way. We're looking more at visuals. They're looking more at other stuff. But I think those are the companies that are in the forefront. I believe, obviously, Applitools is the leader.
In terms of the companies that are actually using those tools, how sophisticated are they?
Well, once you use tools that use AI, you're not using AI. We take away the difficulty. You don't need to learn machine learning. I don't need to learn. It's very, very complex. We need PhDs for that. Those companies, including Applitools, take away that need. You just use it. Just like a farmer doesn't need to understand how a tractor works. AI tools, you don't need to know how machine learning works or deep learning works. You just use those tools.
I think we'll need to wrap up. Thanks, Gil.
Thank you.
Appreciate it.